Hello, Wayland Middle School's Mr. Farley here. Today I'm going to talk to you a little bit about factoring using the greatest common factor, or we will abbreviate that as GCF. So what we have down here in some of these examples, this is the first one. We have 2x plus 4y. So what you're going to do in order to factor this binomial, this is a binomial, we're going to factor it by taking out or factoring out a common factor in both of these terms. I think everyone is probably thinking that 2 is common in both of these terms. So if you look over here to the right, you'll see that I factored out a 2, and then I'm going to add some parentheses. These parentheses here is the leftover. It's what's left over after factoring out the 2. I take a 2 out of 2x, I'm left with x. I take a 2 out of a 4y, I'm left with 2y. And I think you guys can see how this resembles the distributive property. That's exactly what we're using here in order to factor out using the GCF. We take the factor of 2, and if we distributed this through, we would get right back to where we started with. So over here on the right-hand side, these are the, when you factor it out, this is what you would be writing. For instance, in the second one, we have a common factor of 5 in both of these. So I'm going to factor out of 5. I take a 5 out of each of the terms, and I'm left with a minus b inside. You have to write both the 5 and the a minus b. These are the two factors of this polynomial. All right. Here's a third example, 18x minus 6y. Again, I hope everyone's thinking, oh yeah, 6 is a common factor. You want to go with the greatest common factor when you do these. So 6 is the greatest common factor of both of these terms. I take a 6 out of both 18x and 6y, and I'm left with 3x minus y. Again, check it using the distributive property. If we go this way, if we distribute the 6 through the parentheses, we end up with the binomial that we started with over here in the original example. I have a few more for you here. On this one here, now it's a little different. We have a little more action going on here. There is a greatest common factor. If I look at the coefficients, I see a 2 and a 6. Well, I'm thinking that a 2 must be a greatest common factor for that. But I hope everyone realizes that in each of these terms, we also have the variable m in both. M is also a factor. So I'm going to pull out a 2m. That's the greatest common factor. And if I divide both of these by 2m, you can see I would be left with 1 minus 3n. Check it. You can check it by using distributive property. And if you distribute the 2m through, you get back to where we started with right here. So again, this is the factored form of this original example here. And finally, we have this one. This has some more action going on. I'm hoping everyone's looking at the coefficients and you see that 5 is a common factor. And then we have also an x is common in both of these and a y. So I'm going to factor out a 5xy, and you can see that's what I did. If I divide the first term by 5xy, I am left with an x inside the parentheses, and divide the second term by a 5xy, and I'm left with a 2 inside the parentheses. If you're unsure about this, you can always distribute this through once again. And if you do that, you will notice you would end up with the same polynomial we started with. So guys, this is factoring using a greatest common factor. Pretty straightforward. But if you have any questions or concerns, please email Mr. Robinette and I will get back to you as soon as possible. Hope all's well, and we'll talk to you soon. Take care.